A very good morning to all of you. I am Yashavant Kanetkar and I am here today to discuss with you how to handle dissimilar data using a data type in C programming known as structures. If you remember, the other day we had figured out how dissimilar data can be tackled using arrays. But there were certain inherent disadvantages when we made use of arrays, and we wish to overcome them today by making use of an entity called structure. We had such data to store names, ages and salaries of employees, where name, age, salary were fields which together are known as a record, and a collection of such records we said is a table. So this tabular data, if we are to represent in memory, as I said, there are two choices. One is create an array of integers, that is ages, create an array of characters, that is names, and thirdly create an array of floats, that is salaries. Disadvantage is what? Disadvantage with this approach is that if number of fields go on increasing, those many more arrays will have to be constructed. And second disadvantage is that natural relationship that existed in the data, that stands completely destroyed when you create an array of names, array of ages and array of salaries. Both these limitations, if we are to overcome, we have to make use of what is known as a structure. It's a data type in C. Let's see how do we make use of it. I have to begin with the declaration of a structure by saying struct employee and then indicate what all fields or elements belong to this struct employee, and that I indicate by declaring that it will hold a character name, a int age and a float salary. This is declaration of a structure. If I ask you a question, how many bytes should be reserved for this struct employee? Well, answer is 0. Why? Because it's a declaration. Declaration, we know, never reserves space. Unless you define a variable, space is never reserved. In that sense, this struct employee is merely a blueprint, merely a template, indicating that tomorrow if you create a variable of the type struct employee, what all will it contain? It will contain a char name, int age and float salary. As of now, is merely a declaration. When I say struct employee E, now space is reserved. How much space will be reserved? If E contains a char name, int age and float salary, then obviously it will be 1 byte for char, 4 bytes for integer, 4 bytes for float, totally 9 bytes. Fine. Not only do I want to define E, a variable of the type struct employee, I also wish to initialize it. And since we propose to create 4 such variables, I would say E1 is equal to A23 4000.5. Similarly, struct employee E2 equal to X27 5000.0 and struct employee E3 equal to Y28 6000.75. Let's create one more variable E4 holding values Z22 and 5600.55. Advantage here is natural relationship now stands restored. It was not so in case of arrays, but it does stand restored because Z22 and 5600.55. So best way to deal with dissimilar data is what? Get it together inside a structure, because the way array is a collection of similar elements, likewise structure happens to be what? A collection of dissimilar elements. Fine. And now to print out the value of each one of names, ages and salaries, we cannot merely say N, A and S. Why not N, A and S? Because E1 contains N, A and S, so also does E2, so also does E3, so also does E4. So whose name, age, salary are we talking about? That has to be clarified. And that can be done when you say E1.N, E1.A and E1.S. Likewise, I will say E2.name age salary, E3's name, age, salary, and lastly E4's name, age and salary. Finally the closing brace of main. So using the dot operator, we can access elements of a structure. Which are the elements of the structure? Name, age and salary. Then what is employee? Employee is the structure name. What is E1, E2, E3, E4? These are structure variables. Terminology, I always insist, is very important. Structure name, structure elements, and structure operator like dot, and structure variables like E1, E2, E3, E4. This also has one serious limitation. Today there are 4 records, so we employed 4 printfs. Tomorrow if there are 400 employees, just to get their data printed out, if you have to write 400 printfs, that is certainly no way of doing things. To overcome this limitation, what we should really be creating is an array of structures. The way to do so is to first declare the structure containing name, age and salary, struct employee, and then create the array saying struct employee E, and then initiate the array to all the 4 records. Fine. So within a structure you can have dissimilar elements, and then these dissimilar elements together can be part of an array of structures. So 0th element of this array is one collection of dissimilar elements. It is similar to the next set of dissimilar elements, is similar to the next set of dissimilar elements. So within the array there is similarity. 0th element, first element, second element. Within that 0th element there is dissimilarity. Structure is dissimilar, but that dissimilar structure is exactly similar to the next dissimilar structure, is exactly similar to the next dissimilar structure. Hence we can create an array of structures. So E in fact is nothing but an array of structures. And once we create this array of structures, just see how efficient does the processing become. Earlier we had 4 printfs. Today we can manage using only 1 printf. Just run a loop and then print out name, age, salary by saying ei.n, ei.age, ei.salary. ith person's name, ith person's name, ith person's salary. When I is 0, this will be e0.n, e0.s, e0.a, and that would take us to this record, 0th record. When I becomes 1, we are referring to elements of first record. When I is 2, elements of this record. When I is 3, elements of this record. So this way processing of all records becomes very efficient the moment these records become part of an array. Finally put a closing brace of main. So any tabular data here on you would ever see, immediately realize that that tabular data can always be managed using one single variable, that is an array of structures. So tabular data can always be dealt with using an array of structures. E in fact is nothing but an array of structures in our program. Advantage is what? That this single variable can tackle any number of records and any number of fields. So let the tabular data have 1000 records and 30 fields in each record. We still need only one single variable. Means as the data volume goes on increasing, my variable names don't go on increasing. I can deal with all records, no matter how many of them exist, no matter how many fields are there in each record, using what? One single variable, that variable being an array of structures. Really a very powerful variable. With that we come to the end line. Goodbye and good luck.